Welcome to our second foundational section to mastering SolidWorks Drawing Tools. In this section, we'll start by exploring relative to model views and auxiliary views. Those will add to our ability to communicate a certain view in a model. We will then learn about model items functions for both parts and assemblies. Those will enable us to automatically export all the dimensions a designer inputted in a part or an assembly into our drawing sheet. We will be covering each of those topics in a separate video lecture, and by the end, we will provide you with exercises to polish and reinforce your skills. So let's get started with our second drawing tools. In this lecture, we're going to explore relative to model views in SolidWorks drawings. Relative to model view would allow us to define our own orthographic views that are different than the ones set by default. We often use this functionality when the default views do not fit our needs. So, let's assume someone gave us this model and asked us to create a drawing for it. He or she specified to us that the front view should be this one. So let's go ahead and do that together. You can download the model from the download section linked to this lecture. We will start by opening a drawing file. So I'll go to new and then select drawings. And then I'll select the first standard 4 pages and then OK. Now I'll simply try to insert the normal or default views. So I'll go to my views, select the model. From the illustrations here, you can see that the views are quite strange. So let's go ahead and see the front view. So it's kind of tilted and it doesn't really fit what we expect for a front view. The side view or the right view looks weird as well. The top view looks weird again. And then the isometric view looks very abnormal. Those were not exactly the views we are expecting. So to tackle this, we can use the relative to model view functionality to define our own front, right, top views. So if you go to the tab, View Layout, you will see all the options we have for additional views. Unfortunately, usually by default, relative view is not included in here. So we can find this functionality in 2 ways. First, we can go to the search bar on the top right. Make sure to have the selection set to Command. So go to the drop-down menu and select Commands. And then you can write relative. And then you'll have the option pops up, relative view. I can simply drag this into my command manager so I can access it more easily later on. Another way to access it is to go to the menus on top, insert drawing view, and then we'll have relative to model option here. So let me go ahead and select that. And when I select it, it actually asks us to select the model we want to work on. So I'll click on the front view we have added earlier. And then the model will pop up. And on the left, you can see the options of setting up the orientation we want for the views. So for the first option, we want to set the front view as this face here, which is instructed by the one who gave us the drawing. And for the second orientation, I'll open the menu and I will select bottom, and then I will specify this view as the bottom view. And then I can go ahead and click on the green check mark. And it will take us back to the drawing, and we have our front view set up. And this is actually the view I want. So I'll go ahead and drop it anywhere here in the canvas and take this away to clear up the way. I can also move this to the left. Now to add in the right top isometric view, I can simply click on this view I just added and then select projected view. And then I can have my right view, my top view, and then my isometric views. Now those views make much more sense than the views we had earlier by default. And now I can go ahead and delete the views I added earlier. So those are our basic orthographic views, and this is how we can use the functionality relative to model view. In many instances, we often get models from other people, and those guys might have designed the model with a strange orientation that don't fit easily into our drawing page. And this is what makes relative to model views a very important functionality. Before we close up this lecture, let's go ahead and use this again to have another view. And this time, assuming I would like to have a view with the inclined surface being parallel to the page itself. Again, if I go check the views I have by default, this view is not really available, so I can use the relative view functionality again. So I'll go to relative view, click on the model, and then for front orientation, I'll select this one, and for the right orientation, I'll select this one, and then click OK. And now I have a view where this inclined surface is directly parallel to the page. We don't really require this view, we just did it for practice, so I'll go ahead and delete it. And this concludes our lecture on relative to model views. So while we're here, you can go ahead and experiment a little with this functionality. In this lecture, we're going to explore auxiliary views in SolidWorks drawings. An auxiliary view is very similar to a projected view, however, it is folded to an edge of our choosing. So for a front view like this, an auxiliary view could look like this. To illustrate how to create an auxiliary view, we will create it on the following drawing and have the following end result. You can download both the part and the drawing files from the download section linked to this lecture. There are two common ways for us to create an auxiliary view. The first way is from an existing edge, and the second way is from a line that we sketch ourselves. Let's start with the easiest way first, which is using an existing edge. So for this drawing, I would like to show the true locations and size of the holes. And I will do this by creating an auxiliary view that is folded around this edge here. So let's go ahead and see how we can do this. I'll go to View Layout on the top, and then I'll select the option Auxiliary View. I'll click on it, and now I will have to pick the edge to which I want my auxiliary view to be folded against. And it is this edge here. So I'll click on it, and that's it. We have just created our auxiliary view. And you will notice that auxiliary views are usually locked around the original drawing. So this auxiliary view is locked around the front view. And it only moves back and forth in the eyesight line. And this generated arrow shows us the direction from which we created the auxiliary view. So this is the first method to create an auxiliary view, which is through an existing edge. This is also the easier and more common way to do this. Let's go ahead and check out the second way. So before that, I'll clear some space on my drawing. And now we'll do my other auxiliary view around this top view I created earlier. And for the sake of argument, let's say I want to have the auxiliary view pointing downward toward that view at an angle of 30 degrees. So to do this, I can go to Sketch and then select Line and simply sketch a line. Now when you create this line, make sure you are inside the view focus of that view. So if I bring in the cursor around this top view, you will notice a pink or purple square. This is called the view focus area for this view. And every view will have its own focus area. So when we draw our auxiliary line view, make sure you are inside that area, and that area is also highlighted for you. So I'm going to draw a random line, and then I'll go to Smart Dimension and set that to 30 degrees. And then go to View Layout, select Auxiliary View, and select that sketch line we just created. And when I do that, you'll notice I get a new view which is an auxiliary view folded around a 30-degree line from that top view we created. And yes, this view looks quite strange. However, we just did it to illustrate how we create an auxiliary view from a sketch line of our choosing. This method allows us more flexibility in choosing our auxiliary view. However, it's also not as simple or intuitive as the first method we explored. So this second view we created just for demo, so I'll go ahead and delete it. And then I'll also delete this line I created. Also, from the views and model I have, I can see that I don't really need 4 orthogonal views to illustrate the model. I can go with showing all the details needed with only the front view and the auxiliary view. So for now, I'll go ahead and delete this top view and this right view. And with this, we conclude our lecture on auxiliary views. So while we're here, you can go ahead and experiment more with this function. In this lecture, we're going to explore model items functions for parts within SolidWorks drawings. With model items, we will be able to easily and automatically export all dimensions we added when modeling a part into a drawing. So with few clicks, we can go from the non-dimensioned drawings on the left to the fully dimensioned drawing on the right. Let's check out how this works. You can download this drawing and the part from the download section linked to this lecture. Using model items is quite simple. At the top, we can go to the annotation tab, and then we'll find the option model items. So let's click on it and see. Now we want the dimensions to cover everything in the model. So we're going to the source, use the drop-down menu and select entire model. And then simply click the check mark. And here you go. We have just finished dimensioning the whole model. However, we're not done here yet. We'll still go over 3 important points when dealing with model items. Point number 1, the locations of the dimensions might not be ideal. So after you apply this function, you would probably need to adjust where the dimensions are displayed to make your work look more friendly. So let's go ahead and do this quickly. Okay, now this looks a bit better. Point number 2, the dimensions imported are the exact ones inputted when the designer designed the part. This has a very big advantage because this way we are guaranteeing the capture of the design intent in our drawings. Point number 3 is about hidden dimensions and other options when using model items. If we look closely at the front view, we'll easily notice that we are missing 2 essential dimensions, which are the height and the width of the main outlining rectangle. This is because whoever designed the part did set those 2 dimensions to not show with the typical straightforward model items option. Let's investigate this first by going back to the model. So if I right click on the drawing, I can select open part, and this will open the original part. Now in the design tree, I'll go back to my first boss extrude and go back to the sketch. Let's go ahead and enter the edit view. Here you notice that the 2 dimensions, 110 and 65, are purple in color. And if I double click on one, you will notice that this option on the far right is toggled off. And this option says mark dimension to be imported into a drawing. This is usually toggled on by default. However, if when designing a part you turn this one off, then this specific dimension will not be imported as we use model items. So in case you want this number to show up, we have 2 ways to do it. First way is to turn this on. Click on the green check mark. You'll notice it turns black, and then go back to the sketch and run the model item again. Now you see the 110 popped up. However, the 65 is not shown yet. This brings us to the other additional options we have when we use model items. So if I go back to model items, I select entire model, and then here you have a title, dimensions, and you have multiple options under it. For now, the only one that is toggled on is the first one, which is marked for drawing, and this will import all the dimensions that are marked for drawing from the part itself. The option next to it says not marked for drawings, and if we click on this option, this will include all the dimensions that the designer chose for them not to show up in our drawing. And then there are lots of other more specific options under dimensions, annotations, and reference geometries that we will not get into at this point. So now if I have the second option, not marked for drawing, toggled on, and then click on the green check mark, you will notice that the 65 appears. Now in my perspective, this information presented in the drawing as it is now are sufficient to deliver my personal design intent. The only thing we have left is to more aesthetically fix our drawing. We can have this up there, we can have this colored, we can adjust the information block and change the scale of the drawing to more fit into the page. We already know how to do all those, so I'm not going back to them again. And with this, we conclude this lecture on model items for parts. So while we're here, you can go ahead and spend some time experimenting with this useful feature. In this lecture, we're going to explore more of the model items functions. In particular, we'll explore the additional options with assemblies. Just to recap, model items allow us to easily and automatically export all of the dimensions we added when modeling into the drawing. To illustrate those assembly model items functions, we're going to complete the following task. So our boss just came to us and provided us with this drawing, and she asked us to find two things for her and add them to the drawing. First is to find the dimensions of all the assembly features in this particular assembly. And the assembly features we have here are basically the two holes. And the second task is to find the dimensions of only the base, which she marked for us in the drawing. Let's see how we can complete those tasks. First task is to find the assembly features dimensions. Just a friendly reminder, assembly features are usually subtractive features that are applied at an assembly level rather than at a part level. And to find those specific dimensions, we can go to model items, and then under source, we can select only assembly. After that, we can simply click on the green check mark, and that's it. We have two additional dimensions popped up in the cross section. Those are this 31.75 and this 1016. And those are the only two dimensions that are specific to the assembly features we have in this assembly, which represent the two holes. Now let's go to the second task. The second task is to find the dimensions of only the base. And to do this, we can go back to model items, and under source, we can select selected component, and then basically click on the base on any of the views. So I'll go to this isometric view and click on the base. And as soon as we do this, you notice multiple dimensions popped up in the top view and also in the cross-section view. And those are all the dimensions related to that base. So to finish, I can click on the green check mark and we're basically done. As usual, we just need to adjust the locations of those dimensions to make our drawing a bit more attractive and friendly looking. One thing we always need to keep in mind when dealing with drawings is the document's measurement system. The document measurement system is set to millimeters, as we can see from the bottom right of the screen. However, it should be in inches, as this is what our bosses specified in the sheet. So we can go ahead and simply change the document's measurement system to inches. And this changes all of the dimensions we have added. And with this, we conclude this lecture on model items for assembly. So while we're here, you can go ahead and experiment a bit more with this feature.